Okay, you've been asked to relate the actual three-dimensional structure of a molecule to its electron dot formula. So let's start with water. With water, you'd be tempted to draw it in a linear form. So you have an oxygen atom with 6 valence electrons, with 2 hydrogens, each with 1 valence electron, which you can then circle or draw a line through to indicate sharing. Hydrogen has 2, hydrogen has 2, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Now you would call that a linear form, which is not entirely correct. What we've observed scientifically with the phenomenon that we've already spoken about with the way that water behaves is that there is an affinity for a neighbouring water molecule with another neighbouring water molecule. And the reason that it has such a strong affinity or attraction to itself is due largely to its bent structure. Now if you see the 2 electrons up here and the 2 electrons down here, they are paired but they're not shared. In other words, they exist together but they're not sharing with another atom. Now electrons we know are negatively charged, and where you find electrons you're going to have a negative area on the molecule. So it'd be fair to say that this area here is quite negative because it has electrons, and this area here is quite negative because it has electrons in the area. Whereas around other areas of this molecule, for instance out here, it's going to be a little bit more positive as opposed to the negativity around these areas of electrons. Now these lone pairs of electrons on the oxygen atom will actually arrange themselves in the following way. They tend to sit high on the oxygen atom and force the other electrons that are being shared down low. I'll circle them this time, but if you put a dashed line there or a circle, it means the same thing. Now if you imagine it, this area of negativity is repelling because like repels like this other area of negativity of this bond. Likewise, these electrons in the bond are repelled by the electrons that sit up high on this molecule. So if you look at the water molecule now, there's a sort of an area of negativity up here. It's like it's got 2 ears that are negative that are pushing these bonds down. And this is sort of really an area of positivity down here as well. So it's the vicinity, the closeness of these electrons that give water its bent shape. So you say that the water molecule is bent. If we compared that, for example, to ammonia. Now you know that ammonia has 5 electrons in the outer shell for its nitrogen, and it has electrons shared with 3 hydrogens. There it is. Now the way that this exists, again, imagine these 2 lone pairs sitting on top of the nitrogen are exerting a repelling force on these negative areas of the bonds between the hydrogen and the central nitrogen atom. So the way that it exists is how I've drawn it there, in a bent form. You may be, these 2 hydrogens here are bent, and this one is also being pushed away. Now a better way to represent that would be to put the 2 electrons here, and you'll sometimes see it represented like this. Out comes a bond to a hydrogen, that's going down. Then you'll see a bond drawn a little bit like this. Better colour him in like the textbook will. To indicate a 3-dimensional shape, that one's going into the page. And then this one indicates a bond coming out from the page, like so. And in this way, you can see that we've got some 3-dimensional shaping to our ammonia molecule. Now you call this a pyramidal shape. It's pyramidal because it looks a little bit like a pyramid. You've got your N at the top with 2 lone unpaired electrons pushing down on sort of the 3 points of a pyramid to make those 4 points. So that's pyramidal. One more that we could examine would be methane. Now methane has 4 electrons in its outer shell. Again, would bond to 4 hydrogens, like so. But again, that two-dimensional shape doesn't really show us how methane exists. Methane really exists in what we would call a tetrahedral arrangement, such that one hydrogen sits right up in the same plane as the carbon. Then you get another hydrogen coming down in a similar plane. One hydrogen will be going away or into the page. I'll draw that H a little bit smaller so it looks a little bit further away. It's like that's going into the page, while another one is coming out of the page. There he is there. This is just a bond. And so in this way, it doesn't look very good, we have a tetrahedral arrangement. And so you're starting to see how your three-dimensional drawings are a more accurate way of representing these electron dot structures. If you go ahead and now use the MollyMod kits to actually construct these molecules, it will bring to life my fairly lame drawings on the page. It's very important, however, that you recognise this shape as pyramidal, this shape as tetrahedral, this shape as being bent, and that you remember that water is a bent molecule.